Hello everyone, my name is D.A. Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. So, in this course related to elements of mechanical engineering, we are studying the CNC systems. This is part 2. Part 1 is already completed in the last lecture. So, we will see what is the CNC systems. So, in the previous class, we will recap shortly what we have discussed. So, in the previous class, we have seen what is numerical control, what is CNC, and what are the basic features of CNC, and then block diagram of CNC, and then we have seen what are the CNC softwares required for any CNC software machine to be working. So in this class, we will see some other things about CNC machines. Now see here, we will see the applications of CNC. So because of the advancement in the technology, lot of new computers are being developed every day. So the CNC machines are also developed in the same manner, where we can increase or decrease the speed. We can increase the speed and decrease the cost of the computer day by day. That is why CNC machines are used more nowadays, because they can produce more products in less time. Okay. Now here we can see there are many industrial operations in which the position of a workhead related to the part has to be controlled. There are many applications in any industry we can take where we have to control the positions of workpieces and tools. Particularly, we are discussing a course related to mechanical engineering. We will be discussing about manufacturing processes or manufacturing technology, where we will use some machines like lathe machine, turning, milling, drilling operations, where we have to control the position of the tool related to the workpiece. So that is why the CNC machines are very widely used in the industries, because they can produce large number of products in less time when compared to human beings, and they can be producing the objects precisely. Okay. Now, in any industrial operations, we will use a machine called CNC machine. So there are two kinds of applications for any CNC. Some are machine tool applications, where we will be working with metals, or some non-machine tool applications where we will be working other applications like packing, storing, material handling operations like this, or controlling the inventory. So these are some of the non-machine tool applications which are related to diverse group of operations in other industries. Now, we will see these two applications in detail. First, we will see machine tool applications. So the most common application in any numerical control is machining of metal parts. So first example for this CNC is lathe machine. So we have seen any lathe machine where we will decrease the diameter of the cylindrical rod, or we can do some other operations like boring, tapping, knurling, thread cutting. So these are some of the applications where we can do these operations on the lathe machine. Now, these can be done manually by a human being. Now we are replacing that with a computer numerical control system. So the most applications are found in machining of the metal parts, rather than controlling the inventory or packing, unloading and loading of the objects into trucks. So these are some of the very few applications. Now mostly the CNC machines are found in machining of the metal parts. Now see here, the common CNC machines are, there are different types of machines are there which uses CNC technology. First one is CNC lathe machine. So here, two continuous path control should be done. There are two continuous path controls in CNC lathe machine. both straight and cylindrical geometries can be turned on a CNC lathe machine. Okay, we'll see what is continuous path control. I will write here path. So we have to see this in detail. Suppose if I have a workpiece, if I want to make a hole at the center of the workpiece, I have some dimensions and the diameter of the hole is there. Now I have a tool which is starting from this point. The tool is initially at this point, like I will point this as a horizon. Okay, so the tool has to move in X and Y directions. So this is X and this is Y direction. The tool has to move respectively both in X and Y directions, so that it will finally reach the center point where it can drill a hole. Okay. Now, in CNC lathe machine, two path controls are possible. Two path controls are means both in X and Y directions I can control the path. So that is movement of the workpiece, that is rotating, and the second one is the movement of the tool. Tool movement also can be controlled in CNC lathe machine. Okay. Now tool can be moved in X and Y directions, and the workpiece which is fixed in the chuck, it can move only in one rotation, that is rotation movement. Okay. So paths. The path starting from the initial point and it is reaching to the final point. Now this path should be controlled in such a manner it will have less movement time. So if I have a same thing I am drawing again. This is a workpiece. I want to make a hole at the center. Initially the workpiece has started here. The workpiece started from this point to center point. I can go in any direction. Like I can go some n units along y direction, and then I will move some units along x direction. Then I will reach the center. Another step is there. I can simply move along x direction first, and then I can go y direction. Okay. So there are multiple paths, but we have to choose a path which is taking shorter time. Which one is taking shorter time when compared to other paths? So if I take the tool, if I move the tool in this diagonal direction where it can reach the center of the plate very easily in less time. So that is why I will choose a path which is taking less time when compared to remaining paths. So this path control can be done in the CNC machine. This path control is very important. So we will study about the path control in robotics, where we will design the trajectory planning. That means we will design the path from which point to which point, how it is moving, how it should move and how it should not move. So everything will be studied in robotic path programming. It's not path programming, it is path. We will design the path in which the direction the robot has to move. Okay. So this is all about path control. The path in which the tool is moving is controlled by CNC machine and CNC lathe. Here we can generate objects, like we can generate multiple objects, mostly straight. Straight means if I take a cylindrical object. So this is a cylindrical object where I can manufacture this using a CNC lathe machine. So this is if I want to decrease the diameter of the entire object, I can simply put the tool here and it will simply cut the material. And here, if I give the feed, okay, if I give the feed towards the right direction, it will remove the material entire length. Okay, so depending on the length, we can change how the workpiece is modified. Okay. Now, in both cylindrical machines, we can get straight or cylindrical geometry. Both straight and cylindrical geometries can be obtained in a CNC lathe machine. And now the second one is CNC boring mill. Now the CNC boring mill is nothing but it is the drilling machine or boring machine which is used to make holes in the workpiece. Now similar to the this process is very similar to turning, where we will take a cylindrical rod and we can simply decrease the diameter of the rod by putting a tool here. If we give the feed, it will decrease the diameter of the rod by removing the extra material from the workpiece. So this is the workpiece and this is the tool. Depending on we can give the feed in this direction or in horizontal direction also we can give the feed. It will remove the material from the workpiece. Now, if I change the position of the tool, now I will place the tool at the center. Now this is the tool. What happens is, at the center of the rod, I will make a hole and I will move this tool towards the right side, so that whenever I am pushing the tool into the rod, it will increase the diameter of the hole. So this process is called boring. So if I am removing the material from the workpiece externally, that is called turning. If I am removing the material from internally, if I have a cylindrical rod, if I am removing the material internally from inside, then it is called boring. Okay. So this process is very similar to turning. Internal cylinder is generated with the process boring mill. So CNC boring can be used to manufacture an internal hole cylinder. So cylinder generally will have internal diameter and external diameter, which indicates there is an internal hole in the cylinder. So these objects can be easily milled by using a boring mill. Okay. So CNC boring mills are used. And then third one is CNC drill press. We have to see in detail what is CNC drill press. Here, point-to-point control has to be done. See, in the CNC lathe machine, we have seen path control, continuous path control. That means in which way it is traveling from point A to point B. So this entire path has to be controlled in case of CNC lathe machine. Now, in CNC drill, we are considering the point-to-point control method, which indicates we will move the tool from point A to point B. We does not care about the path it followed, but it has to move from point A to point B. There is no path control. It can go in any direction. Any direction it can go, and finally it has to reach the point B. So when comparing both the continuous path control and point-to-point control, which one is better? So with the logical thinking, we can simply say the continuous path control is very better, because it is not wasting any time by roaming around any place. It is simply going in the path. It is taking the shortest path between point A and point B. It is not taking any random path, so that it wastes very less time. Okay. Now we have understood what is point-to-point control. I have to move the tool from point A to point B without considering the path. Okay. Now in CNC drill press, where we are making holes. Okay, in CNC drill, mostly drilling machines are used for making holes in the object. Suppose I have a plate. I want to make two holes in this plate. I will make the tool move from first point. Suppose this is point A. Suppose at point A it will make a hole, and then from point A it will move to point B. Then again it will make another hole. So the path is not a mandatory description here. Only the point is we have to make the tool move from point A to point B. Simply it has to make holes. Okay. Now see here, 6 to 8 drill bits are fixed to the CNC drill press. So what are drill bits? We should know what is a drill bit. In the previous module we have seen what is a drill bit and how it is used for making holes. See here, 6 to 8 drill bits can be attached to the drill press. Okay. Now I will draw a small diagram. So this is a This is a tool post where we can fix multiple drills. So each line 1, 2, 3, 4, 5, 6, 7, 8, 9. So more than one tool can be attached to this tool post, and this tool post can be rotated, and it can be, suppose if I have position 1, what happens is tool 1 will be touching the workpiece. Now if I change the position slightly, now I have position 2. Now the tool 2 will be touching the workpiece. Now by changing the position of the tool post, I can change the movement, and I can change the operation done by the tool. Each tool is separate. I mean, each tool is different from other. Okay. Now, what happens is 6 to 8 different drill bits can be attached to the tool post. Why 6 to 8 drill bits are fixed to the tool post means, so if I want to make drills of different diameters, then I will need this different drill bits. So one drill bit has different diameter when compared to other drill bits. So 6 different drill bits can be attached to the same tool post, and this tool post can be rotated and it can be used for making different holes of different diameters. And then another CNC machine is milling machine. So CNC milling machine is also used to remove the material from the workpiece, where it will be moving continuously. There are different milling machines are there. So here also we have to follow continuous path control, where the path is also an important thing here. From point A to point B, it has to move. It should take a particular path. I am not saying a shortest path, because while we are machining, while we are milling, the removing of the material should be done in a particular way. Okay, so the continuous path control is very important. In this milling machine also we will follow continuous path control, where we can get only straight cuts. Okay, like I will draw a small diagram how to get a straight cut with the help of a milling machine. Suppose what is milling operation? Suppose I have a workpiece, I have to make a groove in this workpiece. Okay, now what happens is I have a tool which is moving from this point A to point B. I have to make the tool move in this direction only. I cannot change the direction. Even though it is a longest path, I cannot change the direction. The path has to be in this direction. So because this is a straight line, there is no need for taking extra time. Suppose if I have a path which is like this. So the tool has to move from point A to point B, and it has to make a groove where we'll get straight cuts. It has to move in this path only, in the curved path only. It should not go straightly. Okay. Now we can simply say that the continuous path is mandatory in a milling machine, where it has to make the tool move in a particular direction or in a path which is required according to the designer dimensions. So mostly we will get a straight cut here. Okay, mostly the milling machines are used for getting a straight cuts. Now the last one, CNC cylindrical grinder. So this machine is very similar to turning machine, where we can replace the tool with grinding wheel. Okay, what happens in CNC lathe machine? We will have a workpiece which is fixed to the chuck, and we will have a tool which is fixed to the tool post. So the tool post, when it is given feed, what happens is the tool will remove the material from. So in CNC cylindrical grinder, this is very similar to turning operation, where the tool is replaced with a grinder. A grinding wheel is attached to the tool post, where it can be used for grinding the metal parts. So what is grinding operation? Grinding operation is nothing but removing very small amount of material from the workpiece. Like very small means it can decrease the roughness of the surface of the metal piece. Okay, so if we want to decrease the roughness of the surface and to make it smooth, so that is when the grinding operation is used. Okay, so if we replace the tool in turning operation, like in CNC machine, if we replace the grinding wheel with the replace the grinding wheel, we can simply use the CNC lathe machine also. It can be converted into cylindrical grinder. Okay, so this operation is very similar to turning machine. Now we'll see the next slide. Non-machine tool applications. So what are the non-machine tool applications means? First one is electrical wire wrap machine. So here the string wires are wrapped on the electrical boards. So when we see some copper windings can be done in any electrical motors or something. So that is when electrical wire wrap machines can be used. So they can be automatically wrapping the wire in such a manner so that they can be formed a stator coil. Okay, so these are mostly used in electronics industry. So electrical wire wrap machines are used in electronics industry where wrapping is very important. And then second application is, so these are all non-machine tool applications. Here we don't have any machine tool. So we'll simply use the CNC machine for different applications. Okay. So the second one is component insertion machines. So these machines are very widely used in electronics industry itself, but they are used for inserting the components, different components into the printed circuit boards. Okay. Now there are some circuit boards. Circuit board means it can be any TV circuit board or anything. So different components like capacitor or something, they can be inserted easily into this printed circuit board with the help of a CNC machine. Okay, so this is mostly used in electronics industry. And then third one, drafting machines. As we all know, CAD/CAM, computer aided design and computer aided manufacturing. These two are directly related to drafting machines. So these are nothing but drafting machines where we can design an object, we can make the object converted into actual hard body, that is the workpiece. Okay, so the entire thing comes under drafting machines where we can use the CNC. And next one is coordinate measuring machines. So the CNC machines can be used for measuring the dimensions of any object. Okay, like if I have a workpiece, if I want to measure the dimensions, I can simply use a CNC machine attached with laser. So this laser machine will measure the dimensions of the body in such a manner it can simply measure the dimensions. It will give the dimensions, area parameter of the body simply. Okay, and then last one is tape lying machine. Tape lying machine means this is used in polymer composite industry where a very thin layer of tape which is made up of polymer, it is used for laying the polymer on the surface of other composite materials so that they can be converted into a very hard plastics. So mostly polymers are plastics. So this tape can be laid with the help of a CNC machine because the path is very particular here. The tape should be laid in such a manner. And then cloth cutting, knitting, riveting. Okay. So what is cloth cutting? Cloth cutting is nothing but simple. We can cut any cloth with the help of a CNC machine. Knitting means we can stitch the cloth with the help of a CNC machine. Like we can replace the sewing machine with the CNC. And then riveting. Riveting is nothing but connecting or attaching two sheets of metal with the help of a single bolt or nut. Okay. So these are some of the non-machine tool applications of CNC machine. And then we'll go to the next slide. So let us see some of the advantages of CNC. So first advantage is non-productive time is reduced. There is no time is wasted when the CNC machines are used. Okay. So non-productive time is reduced. And the second point is greater accuracy and repeatability. Greater accuracy and repeatability is attained with the help of a CNC machine. Okay. Accuracy means we can make the objects or workpiece at the very given particular dimensions given by the designer. And repeatability can be obtained. So repeatability, how can be obtained? When we are manufacturing an object, when we are using a human being in the place of a CNC machine. So he cannot produce all the objects of same dimensions and size. So that is when we have to use a CNC machine because a human being will get tired easily and he cannot produce all the objects of same dimensions. Some human errors will come into picture when he will be working for long hours. So that is when CNC machines are introduced where they can produce n number of workpieces in a given time. And then low scrap rate. So whenever we are using a CNC machine, the scrap which is obtained while we are machining an object is very low. This can be decreased with the help of CNC machines only when compared to human beings. Even though some scrap will be there in both conditions, but in CNC machines it is low. And then inspection requirements are reduced because the CNC is a machine. It can operate on its own and it will be precise. So the inspection requirements are very less. There is no need to inspect the object again and again because it is not done by a human being. So there is no need for inspection again and again. And then more complex part geometries are possible. Now, whenever there is an object, we can generate part geometries. More complex geometries are also possible with the help of CNC machine. Okay. Now CNC machines are very rampant in these days. They can be used for producing complex objects. Okay. And then engineering changes can be accommodated more gracefully. So if the machine is doing an operation, the CNC machine is working. In this working condition, we can make any changes to the design. Like when the machine is in the dynamic condition, we can change the code and we can change the output object. So these are called engineering changes where they can be accommodated more gracefully. Okay. And then next point is reduced part inventory. Here the machine is using the tools or parts. So when compared to human beings, the machines will use the tool very safely and it will not push the tool above the limit because we can program that also. So the part inventory, whether the workpiece or the tools, they can be used for longer period of time. And then less floor space is required. Suppose this comes into picture when a single CNC machine is used for multiple operations. Suppose I have a CNC machine, it can do both turning and drilling. I have saved one extra space of a drilling machine because if I want to do this manually, I have to use two machines. One is lathe machine and another one is drilling machine, where I have to accumulate both machines in an area. Now with the help of CNC machine, those two machines can be combinedly, those two operations can be done by a single CNC machine. Okay. Now, operator skill requirements is also reduced. Simply, you don't have to do the operation because you have skill. Okay. So, the operator skill requirement is reduced because you don't have to practice more and more on the workpiece to get better precision. Simply, we can give the codes to the computer. Maybe coding it will take some time, but giving the code to the computer, it will convert that code into required dimensions of the body, and it will simply manufacture the object. So these are some of the advantages of any CNC machine. Now we'll see what are the disadvantages of CNC. So additional cost for installation is required because we have to purchase a machine which is fitted with computer numerical control. So this is the extra burden for any institute or organization. Okay. So the additional cost for installation is a major disadvantage in this manner. But once the CNC machines are installed, they can produce more objects when compared to conventional machines. And then second one is higher investment cost because cost of installations is more. We have to invest more for installing the entire system. Higher maintenance effort is required because the CNC machines are very complex. Even though they will give the required diagnostics report and maintenance reports, still the maintenance of CNC machines is very costly when compared to conventional machines. And then part programming is the skill which the operator requires. The operator should know how to write a program in the computer so that he can simply write the program for cutting the object in such a manner it should meet the requirements of the designer. And then higher utilization of NC equipment. So there are a lot of numerical control equipments are being used. Those equipments are very costly, so that using those equipments will increase the NC it encouraged the investment. Okay. Now, so this is all about CNC machines. So we'll see the next topic in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.